Hello students, once again welcome you to GK's maths classes. Today we are going to start a new chapter called inverse trigonometric functions, Cbse class 12th. In this video we are going to basically do only the introduction and also the graph, and if possible we'll try to do some formulas. Problems related to inverse trigonometric function, hopefully we'll do it in the next video. So kindly subscribe to my channel and also click the bell icon to get notifications on videos that I post later. And I also wanted to mention here that I have started a new series of JEE mains coaching where I solve every day 5 problems. Okay, so that will be easy for you to cope up along with your schoolwork. So I hope it will be beneficial to you. This is a video for even 11th as well as 12th. 12th standard students, it's a revision of 11th standard. For 11th standard students, it's a new thing. It's under JEE mains. The questions are good. You please refer to it. I will try to put the link in the description box. Okay. Now with that, we'll start with this chapter. Now, what is inverse trigonometric function? Now, inverse trigonometric function means, first of all, I should understand what a function is. We all know what a function is. If I say f is a function, from A to B, if f is a function from A to B, then what do you say? Every element in the domain is mapped to a unique element in the codomain, correct? So the idea is every element in the domain, here my domain is capital A, is mapped to a unique element in the codomain. So that is set B, correct? I'll just draw some situations, okay, like few situations to understand whether it is a function or not a function. First, we should know what a function is. This is just a revision of function that we have done in 12th standard, chapter 1. Now, is this a function? Yes. Every element in the domain is mapped, and 1 is mapped to only one element, 2 is mapped to only one element, 3 is mapped to only one element. So every element in the domain is mapped to a unique element. Here unique means one element in the codomain. So this is my A and this is my B. Let's take another situation. 1, 2, 3, A, B. Suppose I have a situation like this. Is every element in the domain mapped? No. Therefore, this is not a function. Not a function. Whereas it's called a relation. Whereas this is a function. It satisfies the definition of a function. Okay. Now suppose if I have A, B, C, 1, 2, 3. Is this a function? Definitely no. Because every element in the domain is mapped, but A is mapped to 2 elements. If A is mapped to 2 elements, it cannot be a function, it's a relation. This is not a function. Okay. Now geometrically, let us try to understand what it is. Now, when a function is given or when an expression is given, first how do I determine whether it is a function or not? Now we have something called the vertical line test. Vertical line test. Now what is a vertical line test? If I have a graph, if I have a function, say x square plus y square equal to 25, you know this is a circle with center, origin and radius 5. It's a circle with center, origin and radius 5. Now vertical line test means if I draw a vertical line, say I draw a vertical line. Now this vertical line intersects the curve at 2 points. Can you see this? It intersects at 2 points. That means for one value of x, suppose this is x1, there are 2 values of y. What are they? y1 and y2. So you have to draw it diagrammatically. If this is x1 and x2, sorry, this is x1, it goes to y1 and y2. This violates the definition of a function. So that is why vertical line test is very useful. If you move this wherever you want, At every point, it intersects the graph at 2 points. So if the graph intersects, if the vertical line intersects the graph at 2 points or more than 1 point, it is not a function. Okay. Let's take another example. Let us take the graph of y equal to sin x, which you know already, which you have studied in class 11th. So look at y equal to sin x. I'll just take one branch of it, y equal to sin x. Now if I draw a vertical line, what happens? If I draw a vertical line, if I move this vertical line wherever I want, it intersects the graph at only 1 point. Therefore, y equal to sin x is a function. Okay, that's why we have a separate chapter in class 11th called trigonometric function. So sine, cos, tan, secant, cosecant, cot, all are trigonometric function. Okay, so the vertical line test helped me to understand whether the given thing is a function or not. So if the vertical line intersects the curve at more than 1 point, it's not a function. If the vertical line intersects the curve at exactly 1 point, when you move that vertical line, then it is a function. I think I'm clear about it. Okay. Actually, we are not doing this chapter on function. We are doing on inverse trigonometry, but I thought I should give you a introduction of all this to go into that chapter. Okay. With that now you have understood what a function is, correct? Now there are different types of function. The first type is one-to-one function. You have one-to-one function. Now what is one-to-one function? The formal definition is given in relations and function, but I'll just give you diagrammatically what it is. See, 3 go to D, 2 go to A, 1 go to C. So this is 1 to 1. Every element in the domain, each element in the domain goes to exactly one element in the codomain. 1 go to C, 2 go to A, 3 go to D. This is a function. Element in the codomain can be left out, but you see 1 goes to only one element, 2 goes to only one element, 3 goes to only one element. Distinct element goes to distinct images. Okay. Now graphically, how do I verify? Suppose if I have a graph, suppose if I have a sine curve like this. Now what do? There's something called horizontal line test. Now what is horizontal line test? If I draw a horizontal line, the horizontal line intersects the graph at 2 points. Here it intersects at 2 points. That means for two different values of x1 and x2, your x1 and x2 is from the domain, but you have the same y value. You see, I call this as y1, I call this as y1, so it goes to the same y value. So two distinct elements go to the same value. It violates, it's not one-to-one. This is not one-to-one. So horizontal line tests help you to determine whether the function is one-to-one or not. Now let's take one example of let me take another example. Let me take a parabola, y equal to root x. Now draw a horizontal line. If you draw a horizontal line, you see at every instant it cuts the curve only at 1 point. If I move this, it intersects only at 1 point. If it intersects only at 1 point, then it is a one-to-one function. Otherwise, it is not one-to-one. So this is not one-to-one, whereas this is one-to-one. I hope this example makes you to understand what a one-to-one function is. One-to-one function is also called injective function. I think you know all that, but this is just a revision. Now what is then the next type of function is onto. Now what is onto function? Onto. The onto means codomain and range are equal. Okay. If f is a function from A to B, if my codomain equal to range, or in other words, every element in the codomain, that is B, have a pre-image. Every element in the codomain, that means it should be a function and no element in the codomain should be left mapped. Every element should be mapped to some element in B. Then it is called onto. Okay. Now if a function is one-to-one and onto, If a function is one-to-one and onto, then you call it bijective. So what have I done till now? I have introduced you to a word called function. Then what are the different types of function? We are just brushing through. It's a one-to-one function, onto function, and then if it is one-to-one and onto, it is called bijective. Now why do I do all this? Very, very simple. If I have a function f from a to b, remember this is a function. That means it satisfies the definition of a function. Okay. This is a and this is b. F is a function from a to b. Imagine this is like your house and this is like your school. You have gone from home to school. Now you have to return back. I have to come back from B to A. I wanted to come back from B to A. Is it possible? It's not possible always. When is it possible then? It is possible only if, so I will say F inverse, reverse, okay? The F inverse from where to where? From B to A exists. That means it's possible. F inverse from B to A exists, or if it's possible, only if F from A to B is bijective. Only when F from A to B is bijective. If F from A to B is not bijective, F inverse cannot exist. You understand? Only when F is a bijective function, it is possible to find F. Bijective means what? One-to-one and onto. Okay? Now we have a slight situation. Okay? Now we are going to go to trigonometric function. Before we go to inverse, we go to trigonometric function. Now in trigonometric function, my domain is set of all angles. Okay? But angles are nothing but real numbers. Okay? Set of all angles. And my codomain is set of all real numbers. Set of all real numbers. Okay? Now, trigonometric function is a function from set of all angles to set of all real numbers. We can say trigonometric function is a function from real numbers to real numbers. It's a real valued function. Okay? So, when I say y equal to sine x, this is a trigonometric function where x is the angle, y is here. Y equal to sine x. X is the angle, y is the range. Now when I say y equal to sine x, my x is angle. So in trigonometric function, x are angles. The input is an angle. And the output, what is the output? Output is y. Output is a number. It's a real number. So when you take, for example, if you take pi by 6, under the function called sine, it will become 1 by 2 because sine pi by 6 is 1 by 2. So when I say sine pi by 6 is 1 by 2, that means I am putting a value pi by 6 with sine. And sine will take pi by 6 to 1 by 2. So input is an angle. Of course, angles are again real numbers. Okay, just for your understanding, I am saying you take angles to real numbers in trigonometric function. Okay. Now we have a chapter now called inverse trigonometric function. So inverse trigonometric function will be from where to where? Inverse trigonometric function will be a function from real numbers to angles, correct? Because you have to come back, you have to, okay? So this is called inverse trigonometric function. For example, I take sine inverse. You can have sine inverse, cos inverse, tan inverse, everything. So inverse, when sine takes angles to real numbers, sine inverse will take from real numbers to angles. So in inverse trigonometric function, the input is a number, output is an angle. But in trigonometric function, the input is an angle and the output is a real number. Even though all are real numbers, I'm just for your understanding, you have to have angle here for sine. For sine inverse, it should be number and the answer will be an angle. Okay, so keep that as simple as that. For trigonometric function, the angles are taken to numbers. For inverse trigonometric function, numbers are taken to angle. Okay, that's one thing. Now there is a big question mark. What is the question? For example, if I take sine 0, Sine 0 is 0. You know, sine 0 is 0. And sine 180 is also 0. Correct? Sine 0 is 0. Sine 180 is also 0. That means 0 and pi goes to the same value. Correct? So definitely sine is not 1 to 1. Sine is not 1 to 1. Sine is not 1 to 1 means sine is not bijective. But according to my definition, what is my definition? Inverse will exist only when f is bijective. So now I have a situation. Sine is not 1 to 1. If sine is not 1 to 1, sine inverse should not exist. If sine inverse does not exist, okay, then inverse trigonometric chapter should not exist, correct? Because sine inverse is possible only when sine is bijective. But sine is not 1 to 1. So how can it be bijective? So if it is not bijective, how can we have inverse? The answer is definitely it has inverse. Then what we are supposed to do? This is what we are going to do. This is where I am going to take you to the graph. Okay, I am going to shift my screen to GeoGebra. I will show you the graph there, and then we'll come back and explain the concepts. Okay. Now let us look at this. It will take a few minutes. Just be patient. So this is a GeoGebra screen. Okay. Now what I am going to do, I am going to draw the graph of y equal to sine x. So in the input box, I will put y equal to capital letters, y equal to sine x. So I got the graph of y equal to sine x. Now if I draw a horizontal line, horizontal line will intersect sine at more than one point. So definitely when you look at it like this, when you look at the function like this, it is definitely not 1 to 1. It is definitely not 1 to 1. Correct? And also you can see clearly the maximum value of sine is 1, minimum value of sine is minus 1. But it is not 1 to 1. It's very clear because sine 0 is 0, sine pi is also 0. So it's not 1 to 1. Then how am I going to talk about 1 to 1? For this, what we do, I am going to hide this for some time. I will hide sine. Then I will go to sine x only from, see this, only from minus pi by 2 to pi by 2. Look at this. This is from minus pi by 2 to pi by 2. Maybe I'll just zoom in a bit. Let me see if I can zoom in. Okay. This is from minus pi by 2 to pi by 2. Look at the graph. This is actually, let me also now show the sine curve. I will change the color to red color so that you see the difference. So this is my sine curve. Okay. See, this is my sine curve. This is my sine curve, which doesn't look like 1 to 1 and on. It doesn't look like, it doesn't satisfy 1 to 1 property. But now what I do, I take only this portion of the curve, this portion. So let me hide the sine. Now I have only sine x defined from minus pi by 2 to pi by 2. Sine x is defined from minus pi by 2 to pi by 2. In this piecewise, in this piece, you see the function is 1 to 1. The function is 1 to 1, correct? Let me write that. From here to here, the function is 1 to 1. So clearly, sine x, when x is from closed interval minus pi by 2 to pi by 2, it's 1 to 1, correct? And what is the maximum value of sine? 1. Minimum value, minus 1. So the range is also minus 1 comma 1. Correct? So between minus pi by 2 to pi by 2, from minus pi by 2 to pi by 2, sine inverse will exist. Minus pi by 2 to pi by 2, sine inverse will exist because sine x is 1 to 1 as well as on to where? From minus pi by 2 to pi by 2. So sine inverse will exist where? Between minus pi by 2 to pi by 2. So does it mean that sine inverse exists only from minus pi by 2 to pi by 2? The answer is no. Now how do I verify that? Now what I do, I go to the next part, n equal to 1. See, first I talked about minus pi by 2 to pi by 2. Now it is from pi by 2 to 3 pi by 2. Look at it from pi by 2 to 3 pi by 2. It's 1 to 1 as well as on to. See, the maximum value is 1, minimum value is minus 1. And if I draw a horizontal line, it will intersect the graph only at one point. Perfect, isn't it? It's 1 to 1 and on to. So it is, sine inverse will exist from pi by 2 to 3 pi by 2. First it existed from minus pi by 2 to pi by 2. Now it is from pi by 2 to 3 pi by 2. Now let me make n equal to 2. N equal to 2. Again, you see, if I just move this a bit, this side, I think it got stuck a bit. Maybe I'll move it here. You see, from 3 pi by 2 to 5 pi by 2, it is again 1 to 1 and on to inverse exists. Now let me go to the negative side. Let me go to the negative side. Minus 1, see, it's 1 to 1 and on to. So clearly, minus pi by 2 to pi by 2 inverse exists. Pi by 2 to 3 pi by 2 inverse exists. 3 pi by 2 to 5 pi by 2 inverse exists. So piecewise inverse exists because it is between minus pi by 2 to pi by 2 is 1 to 1 and on to. 3 pi by 2 to 5 pi by 2, 1 to 1 and on to. So at every interval, the function is 1 to 1 and on to. Therefore, inverse exists for sine x. So y equal to sine x, if you look at it just like that, you feel as if inverse does not exist. But if you break it into small intervals like minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2, 3 pi by 2 to 5 pi by 2, and so on, inverse will exist. So in that way, you have exhausted all values of x. Isn't it very beautiful? So this is the graph of sine inverse. Okay, this is a graph of sine x. Now, what is sine inverse? Sine inverse is basically reflection of any inverse, for that matter, not necessarily trigonometric inverse. Any function, the inverse is determined by reflecting that curve about the line y equal to x. If you take y equal to x and reflect this curve, you get sine inverse. You see how. I'll just show you. I will take y equal to x. See, this is a straight line. Okay. Now let me change the color slightly so that you see the difference. It's blue. I'll make it blue. Just a few minutes. It will take some time. Okay. It's blue. Now I'm going to reflect. I'm going to use the reflect tool. Click the curve and click the line. You get the inverse function. Okay. I will hide sine. I'll hide the line. So this is the graph of sine inverse. This is a graph of sine inverse. I already drew the graph of sine x. So this is the graph of sine. How did I get? By reflecting sine x about the line y equal to x. Similarly, you can get for all other cases. Okay. Now I have understood for sine x. Okay. Now let me understand about cos x. Let me type the graph y equal to cos x. My God, this is not onto. This is not 1 to 1. Cos x is not 1 to 1. If I draw a horizontal line, it will intersect the graph at 2 points. So it is not 1 to 1. So cos x cannot have inverse. So then there must be some logic. What I should do? The logic is very, very simple. See this. I will hide this for the time being. I have already done for cos x. Watch this. Look at this. From 0 to pi, it's 1 to 1 as well as on to. 0 to pi, it's 1 to 1 and on to. Therefore, cos x is 1 to 1 and on to in 0 to pi. Therefore, inverse exists there. Now, just like before, if I make n equal to 1, what will happen? You see, between pi to 2 pi, the function is 1 to 1 and on to. Since the function is 1 to 1 and on to between pi to 2 pi, the inverse will exist. And so on, you can describe the entire thing. You can talk about sine, cos, tan, cot. Okay, so same explanation. So For sine, it is minus pi by 2 to pi by 2. That is a starting block. For cos, it is 0 to pi. Okay, not that it exists only from 0 to pi. It exists for all values, but the starting is 0 to pi. So that is why they are called principal values. Minus pi by 2 to pi by 2 for sine is a principal value. 0 to pi is the principal value for cos. Okay, all other are values, but these are the principal values because that's why you make a beginning, something like a midpoint. Okay, now let me close this. I'll just show you for other curves. Maybe for tan I'll show you. Look at tan. Let me make it 0. See, this is a beautiful curve of tan, one part of tan from minus pi by 2 to pi by 2. Here minus pi by 2 and pi by 2 are not included because tan pi by 2 is undefined, tan minus pi by 2 is undefined. Therefore, you see, this is 1 to 1 and on 2. 1 to 1 and on 2. Therefore, inverse exists. Okay. So, it exists from where? Minus pi by 2 to pi by 2. Similarly, for all other cases. The same argument goes for all cases. Maybe I'll just show one. Maybe I'll just move this and show you. See this? If you move everywhere, it will be 1 to 1 and on 2. Can you see it? Very beautiful. Now let's go to cosecant. You have to tell me. Cosecant, you answer to yourself. You see from minus pi by 2 to 0, and then from 0 to pi by 2 it works. Minus pi by 2 to 0, 0 to pi by 2, it's 1 to 1 and on 2. 0 is not included because cosecant 0 is undefined. That's why there is a break at 0. Can you see it? Very nice. If you understand the graph of cosecant x, you will know everything. For cosecant x, x cannot be 0. So that is why it's minus pi by 2 to 0, and then from 0 to pi by 2. 1 to 1 and on to, so inverse will exist. So here also it is minus pi by 2 to pi by 2 excluding 0. Okay. Now let me take you for secant. What will be for secant? You can see clearly secant pi by 2 is undefined because secant is 1 by cos, cos pi by 2 is 0. So 1 by 0 is undefined. See, between 0 to pi, it's 1 to 1 and on to, but you can't say 0 to pi. You have to remove pi by 2 because secant pi by 2 is not defined. And finally, let's go to cot. Look at the cot. Again, it is 0 to pi by 2. Just like tan, it is 0 to pi by, it is 0 to pi. 0 to pi, it's 1 to 1 as well as on 2. Therefore, inverse exists. That is why in your NCERT book, if you see, there's a wonderful table given. We'll go back to our page. Look at this graph. Look at this table. This is what I put in the beginning. For sine inverse, okay, I told you for sine inverse, for inverse trigonometric function, input is number. So this is my domain. This is my domain. And you saw yourself that the maximum value of sine is plus 1, minimum value is minus 1. Correct? And the graph was from minus pi by 2 to pi by 2 closed interval. Because sine pi by 2 is 1, sine minus pi by 2 is minus 1. Well defined. So this table is something, is not to by heart, it's for you to understand. From the graph which I showed you, I'm sure you should be able to understand now. Now look at cos inverse. Cos maximum value is 1, minimum value is minus 1. Minus 1 to 1. And you have noticed very carefully, 0 to pi it was 1 to 1 and on to, therefore inverse exists. That is why this is called the principal range. Called the principal range. There are other ranges, but this is the principal range, 0 to pi. Now look at cosecant. I have told you cosecant take all real numbers except minus 1 to 1. If it takes minus 1 to 1, then sine will be more than 1. So that is why open interval minus 1 to 1 is removed. For cosecant will take all real numbers except values between minus 1 and plus 1. And as I saw in the graph very clearly, the cosecant is minus pi by 2 to pi by 2 excluding 0. You know why? Because cosecant 0 is not defined. Now look at secant. Same argument. Secant takes all real numbers except open interval minus 1 to 1, because if secant takes value less than 1, then cos will become more than 2, which is not possible. So secant also is 1 to 1 and on to from 0 to pi, but pi by 2 is removed because secant pi by 2 is undefined. That's what I've written here. Now tan you saw it was like a asymptotic, it was like a x cube curve. It is all real numbers. It takes all real numbers and open interval. It is not closed interval, it's open interval minus pi by 2 to pi by 2, because sine pi by 2 is undefined, tan pi by 2 is undefined, tan minus pi by 2 is also undefined. So you cannot include pi by 2 and minus pi by 2. Big difference. Closed interval means the values are included, the boundary values are included. Open interval means boundary values are not included. Now cot inverse again it is same as tan, all real numbers, the domain is all real numbers, but it takes value from 0 to pi because cot 0 is undefined, cot pi is also undefined. Okay, I hope this table is clear. If you have any doubt, you can always rewind the video and see the graph of each and every graph I've showed you. You can pause it and check whether whatever I said is acceptable to you or not. If you still have a doubt, you can always put your message in the comment section. So for me, the most important part of inverse trigonometric function is talking about this particular table which is there in the NCERT, which cannot be by-hearted. It has to be understood. Very, very important. Just as a recap, I just want to go back to the graph and show you this again so that it's become very clear to you. Just a few seconds, please. Okay. Now, once again, I'll just be seated. Let me see. Okay. Now, again, I want to talk to you about sine inverse. I'll close this cot. Look at sine inverse from minus pi by 2 to pi by 2. Maximum value is 1, minimum value is minus 1. That is what we got. If you take a textbook and see, because I'm not able to put that here, so I think it's clear. Look at cos. Look at cos. The maximum value is 1, minimum value is minus 1, so closed interval minus 1 comma 1, and it is from 0 to pi. Closed interval 0 to pi. Now look at tan. It's all real numbers. Y takes all real numbers. Everything is included. Now you see here, it is asymptotic to minus pi by 2 and plus pi by 2. The graph will never intersect. It will never cross pi by 2. Correct? So because tan pi by 2 is undefined, tan minus pi by 2 is minus infinity. Is it clear? So it is open interval minus pi by 2 to pi by 2, but your domain is all real numbers. Similarly, now let's go to cosecant. Look at cosecant. You will not get any graph in between this. Between minus 1 and 1, you will not see the graph of cosecant. But from minus pi by 2 to 0 and 0 to pi by 2, it's 1 to 1 and on to. If you draw a vertical line, it will intersect only at one point. Okay? So the answer will be all real. This is for the principal range, it is minus pi by 2 to pi by 2 except 0. See, 0 is excluded. Once again, we'll go for cosecant. Secant. Now what is secant now? It's all numbers from 0 to pi, but pi by 2 is excluded. Can you see? Because secant pi by 2 is not defined. Now finally, we come to cot. What do you get? When you come to cot, it is from 0 to pi. You see, it is from 0 to pi. 0 is not included, pi is not included, because cot 0 is 0, cot pi is also, cot 0 is infinity, cot pi is also infinity. It's not defined. Now quickly, I'll just show you how to draw the graph inverse of each one of them. Okay, y equal to x is the line. I'll just close all this. Now I have already showed you sine, just you have to reflect it. Okay, see, this is one branch of it. If you want to know the entire sine inverse graph, you have to type y equal to arc sine x. Arc means sine inverse, arc sine x. Arc sine x. Just a second. See this? Y equal to something is wrong. Y equal to arc sine x. That should give me arc sine x. I don't know why it is not coming. Okay. Okay, it is giving only one branch of it. That is the problem. Okay. Or the easiest way it will be, I'll type sine x. I'll type sine x and I'll try to reflect sine x about the line y equal to x. This is the graph of inverse. I just zoom, see. So this is the graph of sine inverse x. Nice, no? Graph of sine inverse. I'll just show you one more. If you want, I can show you the graph of just a last thing. I'll take y equal to cos x. I'll take tan x maybe. Y equal to tan x. This is the graph of tan x. Now how do I find the inverse? Very simple. Just reflect tan x about this line. That will give you the entire reflection of tan x. You see? So like that you can do for anything and everything in GeoGebra. It's a very wonderful tool. If I want to draw only one piece of it, you see, if I take tan, this is not the entire one second, this is tan, one piece of it. How do I find the reflection? Take the reflection tool, reflect about the line y equal to x, you get the graph of, so this is the graph of tan inverse x. So I hope you understood. So the first thing we talked about today is what is the function is, what is a one-to-one function, what is an onto function, when will an inverse exist. Then we also had a confusion about whether trigonometric function can have inverse because it looked like sine, cos, tan are not one-to-one and onto. Then we broke it into small pieces of interval and understood how the function is one-to-one and onto, and through graph I was able to do it. These graphs are not so difficult. Maybe I'll put a separate video to make you understand how to do these graphs. I will teach you that later. And we'll do more problems and more formulas in the next class. Kindly subscribe to my channel and also press the bell icon to get notification. I hope this video was very useful to you. See you again in the next video. Have a wonderful day. Bye-bye.